So this video is on notes that we added in today on theorems that we put in the back of the composition book on similar triangles. And we also added into the front a side splitter example that I will go over next. So into the back of our composition book, we added this, okay, to the back of our composition book. And on this, you see that we have similar triangle theorems here. So first one we have is angle, angle, angle. So in that situation, angle A is congruent with angle D. Angle B is congruent with angle E. If two angles are congruent, then the triangles will be similar, and the converse is there also. The next one that we talked about was side, side, side. And when we're dealing with this, you have to pay attention to ratios. So in my original triangle A, I am multiplying it by something and I get K times A. I'm multiplying B by something to get K times B. And I'm multiplying C by something to get K times C. So for this, we would need to set up our proportions. So I would say KA over A equals K, and KB over B equals K, and it has to be true for the third one. So KC over C equals K. And so by similar SSS, these two triangles are going to be similar because everything in this triangle is being multiplied by K to get the other triangle. And so our scale factor for each of the side ratios ended up being K. For side angle side, similar idea that we had of over there. So we have this angle here is congruent to this angle here. And then what you want to pay attention to is this side here is going to correspond with that. And this side here is going to correspond with that. And so you'll notice that the angles in between those two sides, that's what has to happen. And then I'm going to do is I'm going to take A and KA and check their ratio, and B and KB and check their ratio. So KB over B is going to give me K. And KA over A is going to give me K. So this triangle is multiplying by K to get the other one. We have a scale factor of K. On the next one here, this is the side splitter. And what happens with the side splitter is you have similar triangles here, where this and this are going to be parallel bases. Okay, they're parallel to each other. And that's not the side that's being split. The sides that are going to be being split, this side here is being split, that purple side, and this teal side is being split. And it's being split in both cases into two pieces. So this B and A are making up the two line segments, lengths. And over here, this is D and C. And so when I have this side splitter, I can only compare sides that are split. So the ones I cannot compare that VT and that SN with either of those little parts. Okay, that cannot happen. So in this situation, I can compare A is to B as C is to D, and I can cross multiply and solve. Okay, that is the side splitter. We also have here that congruent parts, corresponding parts being congruent, the triangles are congruent, and the converse. If the triangles are congruent, then their corresponding parts are congruent. isosceles triangle. So in this diagram, we have an isosceles triangle. And if it's an isosceles triangle, then the base angles have to be congruent. And the converse is true. If the base angles are congruent, then the triangle is isosceles. Over here, we're dealing with the exterior angle theorem. And for this exterior angle theorem, if you're looking at this picture, we have this triangle where one of the sides is being extended, and that is forming this angle X, which is our exterior angle. And what is going to be true is that the sum of that exterior angle, okay, the sum of that exterior angle is going to equal our the sum of our two remote interior angles. Okay. And again, this is our exterior angle. So if I take X is going to equal the sum of the other two, which is going to be A plus B. Now, the reason that's true is because of the following. So again, I kind of took it off of here, but what's going to happen is this angle here, which is our exterior angle X, is going to equal the sum of these two remote interior angles. And I was saying that the reason of that is going to be because of the following. This angle C and angle X together make 180. So I know that X plus C is equal to 180 degrees because they are a linear pair. I also know that I have a triangle here. And so this triangle, the angles in the triangle add to 180. So I'm going to have my C plus my A plus B equals 180 degrees, which is because of triangle angle sum theorem. And so what I know is going to be true is the following, okay? This C is going to add with X to get 180. And this C is going to add with this A plus B to also get 180. So what that means is that the X and the A plus B are going to be equal. Again, that is the exterior angle theorem. These are properties of equality, okay, that allow us to solve equations by adding to both sides, subtracting to both sides. So those are here. Sometimes we will refer to some of these properties when we're doing some proofs. The one I wanted to focus on is this one right here. Reflexive property for congruence. So we have two of them here talking about the sides that are the same and talking about the angles that are the same. And so if I'm talking about the angles that are the same, if I'm talking about the angles being the same, I'm going to draw a picture of both of these situations. So for the one with the sides being congruent, if I was to draw a rectangle, for example, and I was to connect it with a diagonal, I have two triangles. Okay, so I have this triangle here. I have this triangle here, and I have this triangle here. Now, if I was to consider this vertex here, A, and this one I'll mark as B. So this one's A, this one's B. So this line segment that I'm going to draw in purple That's hard to see the purple. I guess I'll just draw it in black. That line segment there is the same in both triangles. So that's what this one here is talking about. That is reflexive property for those sides. And then if I have a triangle, so let's say I have a triangle and I have something like this. So similar triangles where one's a dilation of the other. And they share an angle. So this angle up here, let's say I call that A. Angle A is congruent to angle A because it is in both triangles. It is in this blue triangle here, and it's going to be in this bigger orange triangle. It's in both of them. So that is an example of similarity, of congruence, reflexive property of congruence. Now, the other thing we added in was a picture like this, which is dealing with the side splitter that we talked about over here. So if you want to copy this into your composition book. So this is going to be side splitter. And I'm actually doing a problem from our D-Day from the other day as an example. And what's important to understand is when can you use side splitter and when can you not? So when to use side splitter. And when not to use it. So if I draw a triangle, and I'm going to split it, and I'm going to label this A. So this is going to be point A, this is point L, this is point S, this is point U, and this is point P. And so you have to use you can use the side splitter if this is actually sides being split. So if I am looking at this side right here, that is being split. It's being split into two pieces. In this case, it's being split into a 12 in our example and a 10. And this side here is being split into two pieces. And this one's going to be split into a 3, and then we don't know, we're going to call it Y. Okay, so if I'm dealing with those, I can use a side splitter. Okay, so I can use side splitter for a U and a S because they are both split into two segments, because they are both split. So if I'm looking at A to U, that is split into two pieces. It's split into AP and it's split into PU. If I am looking at AS, that's split into two pieces. It's split into AL and to LS. That that's when I can use a side splitter. When not to use the side splitter. So if I'm looking at this, let me do it in, I'll do it in the teal. This PL and this US, that's when I cannot do it. Okay. So, can't use to find either PL or US since not split. Now in our situation, this is going to be a 10 and this is going to be X. We're going to find that. Okay, so I am going to do this problem solving for Y, and then I'm going to do this problem solving for X. So to find, I'm just gonna make this a little thicker. To find Y, I can do it two different ways. This one is, I'm going to not use the side splitter and I'm going to use the side splitter. Okay. So, my first way is, I'll word it this way. I'm going to say whole to whole side to whole side. And so if I'm thinking about that, let me just kind of draw a situation. I'm going to do it with this. Make it a little thicker. Okay, so let's say I actually have this triangle here. Okay. And move it down here. And then let's say I have this triangle here. This is where I'm thinking of whole to whole. So this whole side here is going to be 22. This side here is going to be a 3 plus y. In the other triangle, this whole side is a 12 and this whole side is a 3. So what I'm going to do is I am going to set up, let's say 3 plus y is to 3 as 22 is to 12. And then we cross multiply and solve. And so when I do that, I'm going to get 36 plus 12y equals, so 36 equals 66. I'm going to subtract 36 and get 30. I'm going to divide by 12. And I actually am going to get a 2.5 when I do that math. And so that is going to be one answer, one way to do it. Another way to do it is to do part and part. So my second way is to do, I'm going to use the side splitter. And I'm going to do part to part. So what I'm going to do is I am going to have this triangle. Let me just redraw it. Let's say I draw it in green. So this is the same situation, but what I'm going to be doing is I am going to be looking at, this was 12 and this is 10. this is 3 and this is y. And I can go y is to 3 as 10 is to 12, cross multiply. I'm going to get 30 is equal to 3y. I'm sorry, 12y. I get the same thing I just had on the other side. Let me just zoom in here. I'm going to get the same thing I had on the other side. Maybe I don't need to write so big. Okay. So I'm going to get 30 is equal to 12y. I divide by 30. I get 2.5 is equal to y. And you can see I got the same answer. So I can do the sides that are split with side splitter or without side splitter, doing whole side to whole side. However, if I'm doing the bases here, this base and this base, I cannot use side splitter. So that's the next thing I'm going to do. So I'm going to be adding on a page, and I am going to do find X. Okay, so I am going to do the same situation. Okay, but for this one, I am going to find X. And for this, I can't use side splitter. Okay, so let me just get the picture back. Get this picture, sorry. I'm just going to copy this. Okay. So in this case, the ones I'm going to be trying to find, this is X and this is 10, and those are not sides that are split. So this side here and this side here, since they're not split, I cannot use side splitter. So I can go X is to 10 as, and when I do this, I have to do the whole entire side here. I got to do this whole entire side, which is 22. So since X is in the bigger triangle, it has to be matched with 22. And then that's going to be over 12. And then I can cross multiply and solve. And when I do that, I get 12x is equal to 220. I divide both sides by 12 and I get an 18.3 repeating. My answer for this better be bigger than that 10 because this is in the bigger triangle. Okay. And it is. And that's the end of our notes.